volume method. And there are two ways that we're going to be looking at today, and then there's also another way called the shell method that we'll be looking at eventually as well. And so the volume method, as we just looked at that three-dimensional object, okay, how it was formed by revolving it around, okay, we can see that there's other objects as well. And so what we're going to do is we're going to look at two methods today. They're essentially the same method, just one of them has an extra step into it. And so the first way we can find it is using what's known as the disk method. And basically, what the disk method means is that I am going to slice this figure into a bunch of disks. Now when they say disks, I want you to imagine if I would take this three-dimensional figure and I would just take a knife and I would slice it. Okay? If you think about it, I would end up having a bunch of cylinders, or something real close to cylinders. That's where the word disk comes from. Okay? And so the thing about all of these disks is they're all going to have the same width. And so what we're going to do is we're going to look at now how you can find the volume of each of these disks. And so first of all, how you find the volume of the disk is you take the area of the disk, all right, times the width. Pretty easy. So now we need to think about a disk. A disk is usually cylindrical in shape, something similar to that. So that's where the pi r squared comes from. Pi r squared is the area of a circle. Okay, and I'm going to take that times the width of the disk, which I'm going to call W. Okay, so that's where the pi r squared W comes from. And notice what it says below. It says to find the volume of a solid of revolution with the disk method, use one of the following. Horizontal axis of revolution. This is your x-axis. Or it could be something other than the x. The first few ones we're going to look at are in fact going to be the x-axis. The vertical axis of revolution is going to be the y. Okay, notice the difference between the two. There's only one minor difference. And what is that?
The x.
The x. So basically, if I'm using a horizontal axis, my equation needs to be in terms of x. If I'm using a vertical axis, my equation needs to be in y. Okay, so that's something for you to understand. So now, let's go ahead and look at this, because this is kind of a breakdown of what we're looking at. Okay, so if we have a horizontal axis of revolution, notice what we do. We spin the object, similar to what I just spun that bell. Okay, I spun that horizontally. Okay, r of x is going to be basically my function. It's going to be this function right here, whatever they tell us that is. Okay, it could be anything. And then I'm going to integrate that from a, which is right here, to b. Notice what they've done with the pi. They've taken that outside since it's a constant. Okay, vertical axis of revolution, and same thing again, except for what do you notice about the disks? They're going to be horizontal, so they're going to be perpendicular versus the other disks. Okay, one of the things to understand, if I'm revolving horizontally, my disks are going to be opposite, they're going to be vertical. If I'm going to revolve vertically, my disks are going to be horizontal. Okay? And so hopefully you can see from that diagram that dx and dy refer to the width of the disk. It's always the same. Okay, so let's go ahead and look at this. Okay, now instead of writing out the words every time, because yeah, it is one of those things that kind of gets long, this just means find the volume of the solid, and I could put solid of revolution, I just didn't put the O and R in there, formed by revolving the region bounded by y equals x squared minus 4x plus 5, x equals 1, x equals 4, the x-axis, and you're revolving that about the x-axis. Okay, so first of all, I want you to go ahead and graph that, and as you're graphing that, I'm going to go ahead and draw out kind of what we're looking at. So what does x squared minus 4x plus 5 look like?
Parabola.
A parabola?
Volume of that one.
Okay.
And
So it kind of looks something like this, right? That's kind of what I'm looking at. I mean, something similar to that. Okay, so really, if you notice, I've got the parabola right there. It's bounded by both 1 and 4. It's also bounded on the bottom here. So really, I'm looking to revolve this region.
what do you mean bounded by?
Bounded by means that those are your limits. It means it can't extend beyond those. Okay, those are kind of like the constraints would be another way you could view that. And so if I go ahead and revolve this, and I'm going to revolve this way about the x-axis, I'm going to spin it. It's kind of going to look like what?
Base.
Yeah, like a base of something. Yeah, that would work. Okay, notice it's going to have a big base here, and this is if we would turn it horizontally. It's going to have a big base here. It might look something like this. Three-dimensionally, of course. Okay, and that's if I would actually turn it. As it is as such, it's going to look kind of like the reverse of that. It's going to look like that.
How are you saying
Take this and spin it. 3 dimensions, just like the bell.
the blue part or the
Okay.
white?
The blue. And so now we need to find the area of that. So to find the, or not the area, the volume of that, because it's 3 dimensions, I'm going to create disks right here. And so first of all, I've got my volume.
I have the
Volume equals pi times the integral of, what are my limits going to be?
BA. 1 and 4.
1 to 4, because those are my left and my right. Okay? Now what I need to do is find the radius, which basically, the radius is the distance from the surface, from where you're revolving it, to the graph itself. So in this case, the radius is going to be nothing more than the function. So x squared minus 4x plus 5 quantity squared. Now I need the width of the disk. The width of the disk is dx. So what I need to do is integrate that. And then I need to evaluate it from 1 to 4. And then take the answer times pi. So to evaluate this, what I'm going to do is square this whole quantity. And yeah, it's going to get kind of messy. And so to square it, I need to take it times itself. Okay, so that's what I'm going to go ahead and do down here. So I've got x squared minus 4x plus 5 times x squared minus 4x plus 5. Okay. So I end up getting x to the 4th minus 4x cubed plus 5x squared. Then I get negative 4x cubed plus 16x squared minus 20x. And then we get 5x squared minus 20x plus 25. So if I add all those up together, I'm going to get
x4
Mhm.
4 minus 8x cubed
okay.
plus 26x squared
Mm-hmm.
minus 40x plus 25.
Minus 40x plus 25. Okay.
Evaluated from 1 to 4.
Right, and you need to integrate it now. We haven't even found the integral yet. That's just simplifying. So if we integrate that, I end up getting x to the 5th over 5 minus 2x to the 4th plus 26x cubed over 3 minus 20x squared plus 25x. And you're going to evaluate that from 4 to 1. Yeah. This one is kind of an in-depth one. Okay, so when you evaluate it at 4, what'd you get? You said 412 over 15? Okay. What does 412? Okay, just a second. Yep, that works. Minus, if you plug in 1, what did you get?
178.
Okay, just a second. Calc value. 178 over 15, you said? Yep. Yes. Okay, so then now 412 minus 178 gives us 234. So you should get 234 over 15 times pi. Actually, I think that'll reduce. 78 over 5. So 78 pi over 5. Now, believe it or not, that's actually the toughest one of the next 3 we're going to look at.
So you
Okay.
don't actually have to know the picture thing, how it looks rotated? I don't understand
No,
that part.
No, it might take a while because I mean you're looking at 2 dimensions and viewing 3 dimensions. So let's go ahead and look at this one. Okay. So now this one, instead of them actually putting it in words, they actually give you a visual to look at. Okay. So let's go ahead. Tell me what we need to do.
We're gonna have to do it around the vertical axis, which means
On this one?
Right. No. No, I mean the horizontal axis.
Okay. So what am I going to do? Volume equals
Pi of 1, 2, 3.
pi from what?
0 to 3.
0 to 3.
Gosh.
Okay. What do I do now?
You plug in 9
Yeah.
9 minus x squared, because that is my radius. That is actually the function itself.
And you can cancel.
And you can cancel them. That's exactly right. So this one, I'm integrating pi from 0 to 3 of really, what answer?
9 minus x squared.
9 minus x squared. So this one actually worked out really nice. Because what's the integral of 9? 9x. What's the integral of x squared?
X to the 3 over 3.
X to the 3 over 3. Good job.
Remember when Mrs. What's her name used to get so mad at us for saying like 2 to 3 or 2?
So
No, I don't know.
Awesome.
now what I'm going to go ahead and do is I'm going to go ahead and plug in 3. And if I plug in 3, now I don't really have to worry about the 0, because if you plug 0 in, you're going to get 0. So when I plug in the 3, I end up getting 27 minus what? 9, which is 18. So your answer will be
18 pi.
18 pi.
100%.
Okay, as I said, we're going to look at one more today, and then we'll save the washer method for tomorrow.
Yeah.
Okay? And so the one more we're going to look at in this case is going to be a what?
Vertical one.
A vertical one. So if we remember when we had a vertical axis of revolution, my function needs to be in terms of what?
Y.
Y. So also my limits are in terms of y.
Oh, that's what
So I'm going to integrate this from this 0 to this 1. Okay, you have to look at it vertically. So then now I don't have a function in terms of y. My function is in terms of what? X. So I have to somehow solve this for x. So how do I undo a 2/3 power? Yep. Say it louder. 3/2. Yep.
Oh, was that what you were talking about one with the other day?
So all you're going to do, in order to undo that, you just multiply by the reciprocal. So I end up getting y to the 3/2 equals x. So my function is actually going to be y to the 3/2, and I'm going to go ahead and square that. So once again, you're going to find out that this works pretty nice because, yeah, the 2's cancel, and it really leaves me with y to what power?
3.
The 3rd. Very good. Okay. So you got to integrate it. So what does that integrate to be? Y to the 4th over 4. Okay. From 1 to 0. Well, when you plug in 1, what do you get? 1/4. So your answer will be 1/4 times pi.
Or pi over 4.
Or pi over 4. So now, if you want to get started on your homework, okay, we will talk more about this tomorrow. This is actually one in which the axis is moved up, and so it's about the line y equals 1, but we'll pick up with that one tomorrow, as we will with the washer method. And so if you want to go ahead and get started, your assignment is on page 463. I need you to go ahead and do 1 through 3, 5 through 8, 11, 13, 15, 16, 19, and 20.